2, Section 2, Earth is a system, energy in the Earth system. Key ideas. As you read this section, keep these questions in mind. What is the difference between an open system and a closed system? What are the characteristics of Earth's four spheres? What are the two main sources of energy in the Earth system? What are four cycles of matter on Earth? Questions to answer, page 17. Why is the jar of tea in the picture considered an open system? What is a system? Earth scientists often say Earth is a system. A system is a group of related objects or processes that work together to form a whole. Highlight that sentence. A system is a group of related objects or processes that work together to form a whole. Systems can be small, as an atom, or as large as the whole universe. The Earth system is made up of many smaller systems. Each smaller system is made up of even smaller systems. For example, one part of the Earth system is the ocean system. One part of the ocean system is coral reefs. Coral reefs are systems made up of even smaller systems, such as rocks and living things. The parts of a system interact or affect one another. Highlight that sentence. The parts of a system interact or affect one another. Systems can also interact with other systems. Systems can interact by exchanging matter and energy. Highlight that sentence. Systems can interact by exchanging matter and energy. Also highlight matter is anything that has mass and takes up space. Matter is anything that has mass and takes up space. Also highlight energy is the ability to do work. Energy is the ability to do work. Heat, light, and vibrations are examples of energy. Open systems. There are two main kinds of systems on Earth: open systems and closed systems. Highlight the next sentence. Highlight an open system is a system that exchanges both matter and energy with the surroundings. The jar below is an open system. Again, highlight an open system is a system that exchanges both matter and energy with the surroundings. This jar of tea is an open system. Both matter and energy can enter and leave the system. Highlight that statement. The question, why is the jar of tea in the picture considered an open system? The jar is an open system because both matter and energy can enter and leave. Again, your answer to question number 1, the jar is an open system because both matter and energy can enter and leave. Page 18, questions to answer. How is a closed system different from an open system? What are Earth's four spheres? What percentage of Earth's water is salty? Closed systems. Highlight the first sentence. A closed system is a system that exchanges energy but not matter with the surroundings. Again, a closed system is a system that exchanges energy but not matter with the surroundings. Answer question number 2. How is a closed system different from an open system? A closed system is different than an open system because only energy moves into and out of the system, not matter. Again, a closed system is different than an open system because only energy moves into and out of the system, not matter. The sealed jar in the figure below is an example of a closed system. Energy can move into and out of the jar. because the jar is sealed. No matter can enter and leave the system. The jar of tea is a closed system. Energy can enter and leave, but matter cannot. Earth is almost a closed system. Energy enters the Earth system in the form of sunlight. Energy leaves the system in the form of heat. Highlight those two sentences. Earth is almost a closed system. Energy enters the Earth system in the form of sunlight. Also highlight the sentence. Energy leaves the system in the form of heat. Only tiny amounts of matter enter and leave the system. Therefore, scientists often model Earth as a closed system. What are Earth's four spheres? The Earth system is made up of four spheres. These spheres are not large, round objects. They are different areas where all of Earth's matter is found. The four spheres are, highlight this, atmosphere, the hydrosphere, the geosphere, and the lithosphere. Again, highlight the atmosphere, the hydrosphere, the geosphere, and the biosphere. That also answers question number 3. What are Earth's four spheres? Atmosphere, hydrosphere, geosphere, biosphere. The atmosphere. Highlight the first sentence. The atmosphere is the layer of gases that surrounds the Earth. The air we breathe is part of the atmosphere. The atmosphere also protects Earth from much of the sun's harmful radiation. About 78% of Earth's atmosphere is nitrogen gas. About 21% is oxygen gas. Highlight those two sentences. Again, about 78% of Earth's atmosphere is nitrogen gas. About 21% is oxygen gas. The rest is made up of other gases, such as argon and carbon dioxide. The hydrosphere. Highlight the first sentence. All the water on Earth makes up the hydrosphere. Almost all of the water in the hydrosphere is salty. Only 3% is fresh water. Highlight, only 3% is fresh water. That will help you answer question number 4. What percentage of Earth's water is salty? Take 100% minus 3%, which leaves you 97% as your answer for question number 4. 97%. Freshwater is found in streams, lakes, and rivers. It is also frozen in glaciers and the polar ice sheets, and is found underground in soil and bedrock. Page 19. The geosphere. Highlight the sentence. The geosphere is all the rock and soil on the continents and on the ocean floor. Again, highlight the sentence. The geosphere is all the rock and soil on the continents and on the ocean floor. The geosphere also includes the solid and liquid rock and metal inside Earth. Highlight that as well. The geosphere also includes the solid and liquid rock and metal inside the Earth. Some natural processes, such as volcanic eruptions, bring matter from Earth's interior to its surface. Other natural processes move surface matter into Earth's interior. The biosphere. Highlight the first sentence. The biosphere is made up of all Earth's living things. Highlight that sentence. The biosphere is made up of all Earth's living things. Organic matter from dead organisms is also part of the biosphere. Once this organic matter has decomposed, it becomes part of the other 3 spheres. The biosphere extends from within Earth's crust to a few kilometers above Earth's crust. Question 5. Label the parts of the photograph that represent the atmosphere, hydrosphere, geosphere, and biosphere. An example of the geosphere would be the mountains that are seen in the background of the picture. Write the word geosphere on the picture and draw an arrow to the mountains. The atmosphere would be the part of the picture where you see clouds. In the area where you see clouds, write the word atmosphere. The hydrosphere would be the area at the bottom of the picture in which the moose is standing. Write the word hydrosphere where it appears that there's water at the bottom of the picture. The biosphere could include the trees, the grasses, or the moose. Write the word biosphere and put an arrow to either the trees, the grasses, or the moose. Exchange of matter and energy. You can think of Earth's 4 spheres as huge storehouses. They store matter and energy. Highlight those 2 sentences. Again, you can think of Earth's 4 spheres as huge storehouses. They store matter and energy. The matter and energy can move from one sphere to another or within a sphere. However, matter and energy can only change forms. They cannot be created out of nothing or completely destroyed. Highlight those last 2 sentences of the paragraph. However, matter and energy can only change forms. They cannot be created out of nothing or completely destroyed. Certain processes move matter and energy from place to place in predictable ways. These processes include chemical reactions, radioactive decay, and the growth and decay of living things. Highlight that entire paragraph. Again, certain processes move matter and energy from place to place in predictable ways. These processes include chemical reactions, radioactive decay, and the growth and decay of living things. Page 20. Questions to answer. What do scientists mean when they say that the energy that enters and leaves Earth's system is balanced? What percentage of solar radiation is absorbed by the atmosphere, land, and water? What are the sources of energy in the Earth system? Highlight the first 3 sentences of the paragraph. They are, energy enters the Earth system in the form of sunlight. Energy also leaves the Earth system as heat. The amount of energy that enters the Earth system is the same as the amount of energy that leaves it. Highlight those sentences. Your answer for question number 6, which is, what do scientists mean when they say that energy that enters and leaves the Earth system is balanced? That means the amount of energy that enters the system is the same as the amount of energy that leaves the system. In other words, the energy that enters and leaves the system is balanced. The diagram below shows what happens to the light energy that enters the Earth system. It also shows how energy is transferred or passed through Earth's systems. Question number 7 asks you, what percentage of solar radiation is absorbed by the atmosphere, land, and water? On the diagram, highlight 19% absorbed by the atmosphere on the left-hand side of the diagram. On the bottom center of the diagram, highlight 51% absorbed by water and land. Add 19% plus 51% to reach a total for question number 7 of 70% Your answer for question number 7 is 70%. External sources of energy on Earth. For living things to carry out their life processes, energy must enter the Earth system constantly. Highlight the next sentence. The sun is the most important external or outside source of energy. Again, highlight the sun is the most important external or outside source of energy. Most living things ultimately get their energy from sunlight. Sunlight also heats Earth's atmosphere, land, and oceans. This heating produces winds and ocean currents that move matter through the Earth's system. Highlight those two sentences. Again, sunlight also heats Earth's atmosphere, land, and oceans. This heating produces winds and ocean currents that move matter through the Earth's system. Gravitational energy from the moon and sun is another external source of energy. Highlight that sentence. Gravitational energy from the moon and sun is another external source of energy. Also highlight the pull of the sun and the moon on the oceans helps create tides that cause currents and help ocean water mix. Page 21, questions to answer. What causes convection in the asthenosphere and mesosphere? What kinds of living things change nitrogen gas into ammonia? Internal sources of energy on Earth. Not all energy in the Earth system comes from the sun. Earth also has some sources of energy that are internal or come from inside. One important internal energy source is radioactive decay. Highlight that sentence. One important internal energy source is radioactive decay. The energy from radioactive decay inside Earth warms the rock below the surface. The heating of rock inside the Earth affects the Earth's surface. Highlight the next two sentences. When rock in the asthenosphere, the mesosphere, and asthenosphere get warmer, it rises toward the surface. Cooler rock that is near the surface sinks. Again, highlight when rock in the mesosphere and asthenosphere gets warmer, it rises toward the surface. Cooler rock that is near the surface sinks. The rock moves in circular patterns like water in a pan on a stove. This type of motion is called convection. Convection transfers heat from within the Earth to the Earth's surface. The heat affects many processes on Earth, such as volcanic eruptions. Question number 8 asks, what causes convection in the asthenosphere and mesosphere? The answer, heating of rock inside the Earth by radioactive decay. Heating of rock inside the Earth by radioactive decay. How does matter move on Earth? Like energy, matter moves between the parts of the Earth system. A place where matter or energy is stored is called a reservoir. Highlight that sentence. A place where matter or energy is stored is called a reservoir. For example, the oceans, atmosphere, and living things are some of the reservoirs for water. The group of processes that move matter between reservoirs is called a cycle. Highlight that sentence. Again, the group of processes that moves matter between reservoirs is called a cycle. 4 important matter cycles on Earth are the nitrogen cycle, the carbon cycle, the phosphorus cycle, and the water cycle. The nitrogen cycle. Living things can use nitrogen to build proteins and other important chemicals. The diagram below shows the processes that are part of the nitrogen cycle. Nitrogen gas in the atmosphere. Lightning changes nitrogen gas into nitrates. Living things can use nitrates to produce important chemicals. Bottom left, bacteria in soil and roots change nitrogen gas into ammonia. Highlight that. Bacteria in soil and roots change nitrogen gas into ammonia. Plants can use ammonia, but they cannot use nitrogen gas. Bacteria in soil and water, on the lower right, change nitrates and ammonia into nitrogen gas. The gas goes back into the atmosphere. What kinds of living things change nitrogen gas into ammonia? The answer to that question is bacteria in soil and roots. Bacteria in soil and roots. Page 22, questions to answer. What are two processes that add carbon dioxide to the atmosphere? Which two reservoirs are part of the short-term carbon cycle? The carbon cycle. Almost all chemicals that make up living things are based on carbon. Like nitrogen, carbon cycles through the Earth system. The diagram below shows parts of the carbon cycle. Highlight respiration and highlight the factory on the right-hand side of the diagram. Scientists often break the carbon cycle into two parts, the short-term carbon cycle and the long-term carbon cycle. In one part of the short-term carbon cycle, plants take carbon dioxide from the atmosphere. They change the carbon dioxide into sugars and other chemicals in the process of photosynthesis. Highlight photosynthesis. The plants use chemicals to build and repair their cells. Animals that eat plants break down the chemicals in the plants. They use some chemicals for energy. In the process of respiration, highlight respiration, they break chemicals down to release energy stored in them. Respiration produces carbon dioxide gas, which moves into the atmosphere. Highlight that as well. Plants also carry out respiration in addition to photosynthesis. Question 10. What are two processes that add carbon dioxide to the atmosphere? Respiration and combustion are two processes. When living things die, bacteria break down their bodies. This process is called decomposition. Highlight those two sentences. When living things die, bacteria break down their bodies. This process is called decomposition. Most of the carbon in their bodies changes back into carbon dioxide gas. Respiration, photosynthesis, and decomposition make up the short-term carbon cycle. Highlight that sentence. Respiration, photosynthesis, and decomposition make up the short-term carbon cycle. In the long-term carbon cycle, carbon moves through all four of Earth's spheres. The remains of some living things are buried underground. Heat and pressure change it into fossil fuels such as coal, oil, natural gas. This process takes millions of years. People burn fossil fuels for energy in a process called combustion. Combustion produces carbon dioxide gas. Highlight those last two sentences. People burn fossil fuels for energy in a process called combustion. Combustion produces carbon dioxide gas. Again, for question number 10, your two answers are respiration and combustion. Question 11, which two reservoirs are part of the short-term carbon cycle? That will be the biosphere and the atmosphere. The biosphere and the atmosphere. Page 23, questions to answer. Where is most of the phosphorus on Earth stored? Which two processes in the water cycle move water from Earth's surface into the atmosphere? The phosphorus cycle. Phosphorus is another element that living things use to build important chemicals. Unlike carbon and nitrogen, phosphorus generally does not exist as a gas. Highlight that sentence. Therefore, it is not found in the atmosphere. Most of the phosphorus on Earth is stored in rocks. Highlight that sentence. Question number 12, where is most of the phosphorus on Earth stored? Your answer, in rocks. Water and wind can break down the rocks and release the phosphorus. It can then flow into the water and soil. Plants get phosphorus from the soil. Animals get phosphorus by eating plants or other animals. The phosphorus in living things returns to the soil when the living things die and decompose. The water cycle. Water is always moving between the atmosphere, land, oceans, and living things. The movement of water is called the water cycle. Highlight that sentence. This movement of water is called the water cycle. In the water cycle, water changes states from solid to liquid to gas and back again. The table below describes some of the processes in the water cycle. Evaporation, water changes from a liquid to a gas. Condensation, water changes from a gas to a liquid. Precipitation, water falls from the atmosphere to the surface. Transpiration, plant leaves release water into the air. Question 13. Which two processes in the water cycle move water from Earth's surface into the atmosphere? Answer would be evaporation and transpiration. How do people affect matter cycles? Human actions can affect Earth processes. For example, when people burn fossil fuels for energy, they can affect the carbon cycle. Highlight, burning the fossil fuels makes carbon move from the geosphere into the atmosphere. This movement happens much more quickly than it would naturally. People can also affect other matter cycles. Many people use chemicals called fertilizers to help their lawns and gardens grow. Highlight the next several sentences. Highlight, fertilizers have nitrogen and phosphorus in them. Therefore, using fertilizers can change the way nitrogen and phosphorus move through the Earth's system. Page 24, question number 1. Answers can be somewhat found on pages 18 and 19. Describe ways that you interact with each of Earth's 4 spheres every day. Give one example for each sphere. The atmosphere, we breathe gases. The hydrosphere, we drink water. The geosphere, we walk on Earth's surface. The biosphere, I am a living thing. You are a living thing. We eat living things. Question 2. Answers found on pages 17 and 18. Is the human body a closed system or open system? Use examples to support your answer. It is an open system because both energy and matter are exchanged with the environment. The matter portion would be food, drinks, things like that as an example. Question number 3 can be found on page 20. How do external sources of energy make matter move through the Earth's system? They heat the land, atmosphere, and water, producing wind and ocean currents that move matter. They heat the land, atmosphere, and water, producing wind and ocean currents that move matter. Question 4, answer on page 21. Describe 2 ways nitrogen gas is changed into forms that living things can use. Answers: bacteria and lightning. Question number 5. What is one way the phosphorus cycle is different from carbon and nitrogen and water cycles? That can be found on page 23. Phosphorus does not exist as a gas and is not found in the atmosphere. Phosphorus does not exist as a gas and is not found in the atmosphere.